Hello and welcome to the old Fliers. Many types of material have been used to build aircraft. In the beginning, it was the most suitable material close at hand, such as wood and fabric. Wood, such as spruce, is lightweight, easy to shape and has some elasticity. When dry, it remains stable, though suffers when wet. Plywood, that has layers or plies laid cross-grain, proved very strong, as shown in a World War II de Havilland mosquito, nicknamed the Wooden Wonder. Its monocoque design with alternating ply and balsa saved weight and saved construction time when Britain had its back to the wall. Fabric, including silk and linen, is easy to cut and shape and apply. Early dopes with nitrocellulose tightened and wet-proofed the fabric. A big drawback was flammability. The Hindenburg airship was fabric covered with nitrocellulose dope. Modern synthetic fabrics include Dacron with butyrate dope. As aircraft evolved, so did the materials used to build them. Using a metal was an obvious choice. Ideally, the metal needed to be strong, workable and light. Aluminium, magnesium, steel, tungsten, nickel alloys and titanium have been used building aircraft and their engines. The electrical wiring uses copper, tin and silver, and batteries required lead and lithium. Aircraft windows contain manganese. Steel, particularly stainless steel, typically comprises 12% of an aircraft and is chosen for its high strength, hardness and resistance to heat. Stainless steel 430F is just one alloy. It contains chromium, manganese, silicon, carbon, phosphorus, sulfur and molybdenum. I counted that there were available 249 alloys of aluminium, 25 of magnesium, 72 of titanium, 47 of copper, 129 of nickel and 187 alloys of steel. Titanium's high strength, corrosion and temperature resistance is appreciated. It would be used more often if not for its high cost. Nickel alloys are ideal for turbine blades due to being able to resist high temperatures. The Wright brothers' first aeroplane's engine was made using aluminium. The engine was painted black to fill the competition. Since then, aluminium has become a highly popular material in the manufacture of airplanes due to a combination of low density and high strength properties, making it ideal for mass-produced commercial aircraft. Aircraft manufacturers prefer to use high strength aluminium alloys, primarily alloy 7075, to strengthen aluminium aircraft structures. This alloy has copper, magnesium and zinc added for extra strength. Aluminium typically comprises around 80% of an aircraft's unloaded weight, and because it is highly resistant to corrosion, it can be left unpainted. Nowadays, composite materials are used in the production of aircraft due to high tensile strength, high compression resistance, low weight and high resistance to corrosion. Composite materials are composed of a base material and resin that strengthens the material as a whole. Composite materials improve fuel efficiency and performance of the aircraft, as well as lessen direct operating costs of the aircraft. The most common composite materials used is fiberglass, that is made up of glass fibres as the base material and a resin matrix. Magnesium is a lightweight metal that was banned in aircraft construction because it easily catches fire. Now, various research studies made progress in developing magnesium alloys that can meet aerospace corrosion and flammability requirements. Due to its low weight property, high strength and ductability, magnesium alloys improve the efficiency of the aircraft. Nano-adaptive hybrid fibres, or fuzzy fibres, have good structural, electrical and thermal properties. Once incorporated into resin products, it will have the ability to be produced in continuous sheets to desired sizes like other fabrics. Fuzzy fibres can be used in small unmanned aerial vehicles where the weight will be reduced when the conductive skin of fuzzy fibre serves for the aircraft's power, sensor systems and communications. Fibre metal laminates have high strength, low density and high elasticity with improved toughness, corrosion resistance, good fire resistance and fatigue properties. Furthermore, fibre metal laminates have low weight compared to other metallic structures. Lesser amounts of these laminates are needed to build a component compared to other materials. With these properties, the cost is dramatically reduced in the construction and maintenance of aircraft. Other materials that can improve the performance and reduce the cost of aircraft manufacturing are Central, that's CENTRALL, reinforced aluminium and ceramic matrix components. Central has 25% more tensile strength than high strength aluminium alloys, high fatigue resistance and high damage tolerance. It also has a lightweight compared to aluminium alloys that will decrease the weight of the aircraft and lower the fuel consumption. Ceramic matrix composites have high resistance to temperatures that exceed the properties of other materials. Its utilisation in CFM LEAP high bypass turbofan engines has reduced fuel consumption by 16%. You might think that carbon fibre is a modern invention, but not so. In 1860, Joseph Swan created some making incandescent globes, as did Thomas Edison in 1879. Roger Bacon in 1958, Akio Shindo in 1960 and the UK Ministry of Defence in 1963 all came up with ways to manufacture carbon fibre. Using carbon composites to build an airplane reduces its weight by up to 20% versus the weight of a traditional aluminium construction. For each kilogram of weight reduction, experts estimate a saving of about $1 million in costs over the life of an aircraft. The search continues to discover materials to build better, lighter, cheaper aircraft. Thank you for watching. Please hit the like and subscribe buttons to encourage new content.